All right, why don't y'all work on these two problems? These two are not one step. These are two steps. Remember how to use molar mass as well, okay? Molar mass might come into play. Remember when we started doing molar mass and y'all hated it so much, and now y'all just do it without even thinking? It's good. You all right?
Yes.
Where are we gonna start? We only got one place to start, right? 4.00 grams. And CH4 is called methane. We'll learn about that in a couple weeks. What are we gonna do? Well, I want volume, but I don't know. Volume is what? What are the units on volume? Liters. Do you know how to go from grams to liters? I don't. Because I can't go directly there. But I can go from grams to what?
Moles.
Moles. Because 16 grams of methane is 1 mole of methane. How'd I get that? Molar mass. Carbon's 12 and hydrogen's 1, and there's 4 hydrogens, right? So grams cancel. Now what do? 1 mole of methane, 22.4 liters of methane. Because it's at STP. So what do we have? Liters. 5.60 liters. Since it's multiple choice, once you write this out, you don't even need a calculator. Watch. 16 into 4, right? That means if I cancel this out and put a 4 down here, 22 divided by 4, 5.6. No calculator needed. You guys love that calculator, don't you? You think you need it for everything. It's your friend. Might be your only friend, huh? Probably not. Not for you.
Probably.
You probably got lots of friends. Me? I don't have any. Because I don't even like the calculator. All right. What about the bottom one? We're going to start with 8 liters, don't we? Of helium. Well, we know that was Shannon that time. All right. What are we going to convert liters of helium into?
Moles.
And how are we going to convert that to moles? 22.4 liters of helium is
1 mole.
1 mole of helium. Why?
Because it's at STP.
Because it's at STP. Now I have moles. I want to go to grams. Molar mass. 1 mole of helium is 4 grams of helium. 8 times 4, 32 divided by 22.4. Don't need a calculator, do I? Not for multiple guess, most of the time. If you sit there and think about it, you can figure it out most of the time. It's helpful to check your work, but it's also helpful to think about the problem and think about whether or not you did it right. Right? Emily forgot her calculator on the last on the midterm. And she still did awesome on it, and I bet I know why, because she did exactly this kind of thing, didn't you? You sat here and thought about the problem. What does this mean? And I can kind of round these numbers off a little bit, and I can make a pretty good guess of what the right answer is on most of them. Okay? Does that make sense? So if you think a little bit, it'll help make your life easier. All right. We already talked about pressures and gas. All right, Dalton's law. There's a lot of laws associated with gases. And the last one we're going to talk about is called Dalton's law. Dalton's law deals with what are called partial pressures. A partial pressure is, you guys know what the word partial means? Right, in dentistry they do partials, right? What's a partial in dentistry?
Not all fake teeth. Like fake teeth, but not.
Fake teeth, but not all of them, right? It's part of it. Like if you get 2 or 3 teeth, right, as opposed to a whole set. Okay? Well, this is called partial pressure because it's part of the pressure. It's not the whole thing together. But what Dalton's law says is that if you take all the partials, all the parts, and add them up, you get the total pressure. Because the gases act independently. When they bump into each other, they just bounce off. And when they just bounce off, that means that they don't act together, so you can add the pressures together. So whether I have 2 or 200 gases in here, if I know the pressure of each gas, if I add them all up, it'll give me the total pressure. So, that number. So here we have, if we're at STP, we have 1 mole of nitrogen is 1 atmosphere. Well, if we have 1 atmosphere, we might have oxygen and helium. This would be a scuba mixture, actually. Or we might have oxygen, helium, and argon. But notice that because we're at STP, the pressure's 1 atmosphere, if I add them all up, they all sum to 1 mole. Because at STP, 1 mole equals 1 atmosphere, right? 22.4 liters. So, yeah. Let's work on a problem. Can you guys solve this? It wants to know what is the total pressure in millimeters of mercury. So what do we have? Well, let's do this one together, and then I'll let you guys do the next one. So what do we have? Pressure total is the pressure from each gas, right? So it's the pressure from the oxygen plus the pressure from helium. Fair enough? Because I only have 2 gases. So oxygen is 0.450 atmospheres, and helium is 855 millimeters of mercury. Can I add these 2 numbers together? Why not? Because they don't have the same units on them, right? I can't add both of these together. So what do I have to do? Well, the answer, it wants an answer in millimeters of mercury, so what do? 0.450 atmospheres. Anybody remember the conversion? Somebody said it. 1 atmosphere is 760 millimeters of mercury. So how many millimeters of mercury is that? 300 and how many? 42. So now I think we can all add, right? So what is that? 1197? And I think they actually rounded off the 2 sig figs. 1200 millimeters of mercury. Okay? Last one. You guys do this one. Requires a little bit of thought. Because you're not just solving for total pressure now, are you? It gives you the total pressure. think about it. What do we have to do? Well, first thing, yeah, we might want to get both of them in the same units, right? And then how are we going to find the pressure of healing? Anybody? Divide? No. Once we have both in the same units, how are we going to get the pressure of healing? Well, what do we know? We have two gases, right? What do we do with the pressures of the two gases? We add them together, right? And that'll give us a total pressure. So how do we get the pressure of helium? Subtract the oxygen from the total, and that'll tell us what's the helium, right? First thing you gotta do is get them both in the same units. So we have what? How many millimeters of mercury is that? I can't do that in my head. What's 8 times 760? 6,080. So that's the total pressure, right? Equals what? P from O2 plus P from helium. If I subtract this from that, I get 4,800 millimeters of mercury equals pressure of helium. So what we got? Everybody sees why? Because by adding two together, I get this for total. So if I take the one I know and subtract it from the total, that gives me the one I don't know, right? How much does it take to fill up this basket? Whatever you want to ask right here. And